All right, applied physics students, here are your homework number 14 corrections. If you're having some problems with some of the homework assignment or some of the answers, I'm going to go over that with you right now. So, the first problem was question number 7. Question 7 reads, in the absence of air resistance, why does the horizontal component of velocity for a projectile remain constant while the vertical component changes? The horizontal component I don't know if I spelled horizontal right. Horizontal, yep. Component, right, which is our left to right. That part is constant or unchanging. And the reason it is that way is because there is no force acting on it, acting on our projectile in a horizontal direction. And again, that's because we are disregarding air resistance. Okay, so we're always going to assume that there is no force acting on our projector in a horizontal direction, which means there's no acceleration. Because remember, our equation for acceleration is our change in velocity over our change in time. To have a change in velocity, we have to have a force present. We either have to have a force present to increase the velocity or a force present to decrease the velocity. If our velocity is constant and unchanging, then I can't have any acceleration either. So that horizontal component remains constant. Okay? But the second part of this, okay, while the vertical component changes, why does the vertical component change? Okay, vertical component, we're talking about, right, our up and down. And this is the part that is under the force of gravity. So gravity is a force that is affecting this, okay, and causing a change in the velocity in the vertical part, which causes a change or an acceleration. Okay, so there's no horizontal component to velocity. So that's question number 7. Question number 8. Okay. Question number 8 says, how does the downward component of the motion of a projectile compare with the motion of free fall? Right, so what this is saying is when I have that projectile and I toss it, right, there's that kind of, if it was inertia, law of inertia, and it just went in a straight line. And it's saying, how does this motion, like this, compare to if I just drop it straight down? Okay, and what we're talking about here is how does this vertical component, this distance it drops between that ideal straight line path compare with the distance that we drop in free fall? Remember, they are identical. Okay, they are the same. So how does the downward component of the motion of a projectile compare with the motion of free fall? It's identical. It is the same because, again, the only force acting on these objects is gravity. And again, because there's no horizontal component of gravity, okay, how gravity affects this object is the same whether my object is been projected and thrown with some horizontal velocity or if it's dropping straight down. So that's question 8. The next one you had to do is number 14. Number 14 says, the vectors represent initial velocities of projectiles launched at ground level. And I'll kind of try to do, well, maybe I'll see if I can get a picture. Let's see if I can get it. I've never tried it this way before, but we'll see. There we go. There's our picture. We'll use that photo. Okay. Change my color a little bit here so you can see it. All right. So there's our projectiles. Letter A says rank them by their vertical components of velocity from greatest to least. To find their vertical components, remember, I'm going to use that parallelogram rule, right? So I'm going to find their vertical components. Right? And so here's their vertical component. I'll put it in a little bit different color. How about if I use this? Okay, so here's this one's vertical component, here's this one's vertical component, here's B's vertical component, and here is A. So rank them by their vertical components of velocity from greatest to least, right? So my greatest, the one with the greatest vertical component, so the longest vector, is letter B. My next longest vector is C. Next I have A. And finally I have D. Letter B says rank them by their horizontal components of velocity from greatest to least. So right, this again is kind of asking for that same thing, but the horizontal component, right? So these horizontal components from greatest to least, right? So the horizontal component, B, is definitely the longest, okay? Next we have D. Then we have A, and then we have C, okay? And again, you could measure them if you wanted to, but you can just eyeball it as well. So that's number 14. The next one you had to answer was question number 30. 30 says a projectile is launched vertically at 50 meters per second. If air resistance can be neglected, at what speed will it return to its initial level? Where in its trajectory will it have minimum speed? So again, this idea here is, here I am with this, I'm this person, and I've launched my projectile up vertically with 50 meters per second of speed. I want to know at what speed will it return to its initial level. So when it's on its way back down, okay, what speed is it going to have here? Now again, we've looked at this with that free fall worksheet that we did. We looked at this on our concept development practice page 5.1 and 5.2, right? This is one of those ones where because I'm at the same height, my velocity will be the same. Okay, it'll be 50 meters per second, but here it was upward. Now it's going to be downward. Okay, so again, the question, a projectile is launched. At what speed will it return to its initial level? 50 meters per second, downward. Where in its trajectory will it have minimum speed? Right at that very top location, when it momentarily doesn't have any vertical component, right? Because our trajectory would have looked like straight up and straight down. So that's number 30, and we have our minimum speed at the top. Last question is question number 34. Question 34 says, Brandon launches a projectile at an angle of 75 degrees above the horizontal, okay, which strikes the ground at a certain distance downrange. So then there's where our projectile hits. For what other angle of launch at the same speed would the projectile land just as far away? Remember, there's kind of a sweet spot with this. The two angles add up to 90 degrees. So to figure out that other angle, I take my 90 degrees and subtract my 75. Okay, which leaves me 15 degrees. So the other angle that I could launch the projectile at, and if I launched at the same speed, it's going to go the same distance, is 15 degrees. I hope that helps if you had some questions on your homework. Have a great day.